देखो, first is law that Q is equal to U plus delta, delta U plus W. Acha, this is for this A to B, you can make out the temperature is not changing. So T1 is constant. T1 is constant, but the gas is expanding. So here what is happening is its expansion is happening. Acha, now if you see, if the volume is increasing, the work is positive. Now why is that? Because if you have a cylinder, the this force by what is the system, the gas inside, it is pushing this, and the displacement is also happening here. So obviously it is positive, work is positive, because both of them in the other force, which is the atmospheric force, is acting from outside, and it is opposing. It's like the delta x is in this direction, so this is doing negative work. So this is the reason why work done on the system by the atmospheric gas outside is negative. So if they ask you, you can always visualize the forces, you know, the forces. Then now this is positive. Okay. Now heat is given to the system. Q is positive, so this is also positive. Okay, this is also clear whenever. So that means I am giving heat here. Now heat is happening. So what is happening to delta U? Delta U is very difficult to sometimes understand. Either you have these two values, then you can calculate the delta U, or delta U is the change in the internal energy. Now that means no work, huh? This doesn't include work. So what we do is, to find delta U, we take any gas in a container and we don't allow it to expand. It's called bomb calorimeter. So the volume is kept constant. If volume is kept constant, the work can't be done. So that is, so what we do is, we are raising the temperature, and this, we are applying heat. So we give heat by some method. So Q is equal to, we know what is Q. Q is equal to uh, MC delta T. But the problem is, we are dealing with not we are dealing with gas, so we generally take this as moles. And what about C? The C can be two types. It can be heating a gas under constant pressure or constant volume, because gas behave differently under both circumstances. So C here is CV, and this is nothing but U, because it can't do work. So this is the relation. If you ever have a doubt, you just do this. See, and this is valid for any any process. Adiabatic, isothermal, doesn't make a damn difference, because we are only worried about U, and U doesn't include work. Now the point is, there is no change in temperature, so this is zero. So this is zero in this A to B. So whenever it's isothermal, work the internal energy changes zero. You can look at this from two ways. One is this formula, that if you have the value of these two, if you don't, then isothermal is quite obvious, it is zero. But under some other, you can. Okay. We will come to that. We will come to that. Change of state doesn't happen here. It's the gas. So you have this. Okay. This is isothermal A to B. So you work with five methods to find the work. So these five methods I will show you. If B is increasing, if B is increasing, that means you are going from this to this direction, huh? This direction. It could be going this or this, whatever. Then the area under the curve, this is the work, and is positive. But if you are going in the opposite direction, then V is decreasing, and the area is actually negative work is being done. Negative work. That means on the system. We are talking of the system. That means the external is like is like somebody's pushing from outside. That's why it's compressing. So this is so and if it's cyclic process, then the area is under the inside the thing. Why? Because from here to here, you it was expansion from here to here was negative work. So what is remaining is this. But if you see, if it's clockwise, then it is positive. It's anti-clockwise, it is negative. Why? Because if you're going from here to here, then this is negative work and this is positive work. So the positive work is less than the negative work. So the direction of so that is also relevant. So in our here it's clockwise. Okay, it's clockwise, and that's why the work is this. And anyway, so we were only concerned with AB. So expansion is happening. Work is done by the system, and you can do it by finding the area under the curve, or you can use the formula this uh, mathematically.